record. Okay, so we're doing, remember, tell me if the paper goes off the screen at all. So we're doing 1.2, and that's the basics of graphs or functions and graphs. There we go. Okay. And the first thing I want to talk about is relations. Okay, go ahead and write that word down. I want you to define it. And relations are a set of ordered pairs. Okay. A set of ordered pairs doesn't always have to be mathematical. We saw it earlier. It could be like button 1 with Coke, button 2 with Coke, and button 3 with root beer. And we put sets of ordered pairs in set brackets. This is an example of a relation. Sometimes relations don't look exactly like this, like a set of ordered pairs. It could be like a mapping. 1, 2, 3, A, B. 1 goes to A, 2 goes to A, 3 goes to B. And I can rewrite this as ordered pairs, but it's already, you know, it represents ordered pairs. 1 comma A, 2 comma B, 2 comma A, sorry, and 3 comma B. Okay, relations. Now the craziest relations don't even look like either of these. I mean, this looks kind of obvious. It's, you know, you can see the 1 maps to the A, the 2 maps to the A, and the 3. What about something like this, though? This implies lots of different ordered pairs, but you have to pick the numbers. And there's an infinite number of numbers in most cases that this represents. I can write some examples of the ordered pairs. I can write 1 comma, let me plug in 1. 2 times 1 plus 1 is 3, okay. That's one ordered pair. How about if I put in 2? 2 times 2 plus 1, okay, that's 5. How about any number, really, 3.1? Let me get my calculator out. 2 times 3.1 is 6.2. That's going to be 7.2. And we use equations when there's just too many ordered pairs, infinite number of ordered pairs. We can't even write them all out, okay? We cannot even write them all out. The difference between these up here and this here, on a graph, these are just individual dots. Down here, there's too many dots, and you have to form a line, okay? So those are different types of relations right there. And we can find the domain and range of any relation. So we did the one earlier with the Coke and the 1, 2, 3. Let's look at the domain and range here. The domain and range here, well, the domain is going to be the set of all the x values. And I see a 1, 2, 3. When I say x values, I really mean inputs. For the range, it's the set of all outputs, and the outputs are either A or B. Notice that we put domain and range in set brackets. Okay. Can you give me a thumbs up? Do you understand everything so far? Thumb sideways if you don't really. Thumbs down if you weren't paying attention, but you should have been. All right, I know everyone's paying attention, so that's good. Okay. Now, over here, for a polynomial function, the domain and range are going to be different. So we're going to wait on that till we get to the equation part of it. But I hope you understand the difference between domain and range at this point. Domain is all the inputs or the things you look at, and the range is all the outputs. Okay. When you look at a graph, you need to look at all the x values for the inputs and all the y values for the outputs. Okay. Now, let me go here. Some, this is an important line, ready? Some relations are functions. Not all relations, but some relations. And they'll have a special characteristic, which I'm going to define in a second. A function, okay, is a relation where each member of the domain corresponds or maps to exactly one member in the range. And I call them members. You could call them elements. A lot of times they're just numbers. Go ahead and copy that down. Those are important vocabulary words today. Domain, range, relation, and function. You can look those up in your book. Now, I want to give you an example of something that's not a function. Okay. I want you to think of the button number in the soda machine like earlier. Okay. Button number, soda. Let's say there's 4 button numbers. Let's say there's 4 sodas. Coke, 7-Up, root beer, and orange. And let's say 1 goes to Coke, 1 goes to orange, 2 goes to 7-Up, 3 goes to 7-Up, and 4 goes to orange. Now, this is not a function. And here's why. I can see that the 1 goes to 2 different sodas. And I want you to imagine that in real life. Can you imagine pushing a button on a soda machine and they say, well, you're going to get either Coke or orange? That doesn't make sense. You need only 1 soda or no soda to happen for each button. Okay? If I were to write this out in ordered pairs, here's the way the relation looks. 1 comma Coke, 1 comma orange, 2 comma 7-Up, 3 comma 7-Up, and 4 comma orange. So you can see there, watch this. See how the 1 is repeated and it goes to 2 different things? This is not a function. The reason? 1 corresponds to 2 different outputs or 2 different y values. Go ahead and copy that. Any questions? Okay, I'm going to change the page, and I want you to determine if this is a function or not. Ready? I'm going to write a relation, a set of ordered pairs. Okay, 1, 6, 2, 6, 3, 6, 4, 6. Is this a relation? Why or why not? Let me call on somebody. Jordan Heen.
Yeah.
Is it a function or not?
Yeah.
Yeah, it's a function. The 1 goes to 6, the 2 goes to 6, the 3 goes to 6, the 4 goes to 6, and those inputs do not go to another number. If we're thinking Coke machines, I want you to think of this. This is a machine that only has Coke. Every button you push, 1, 2, 3, or 4, Coke comes out every time. It's one of those kind of machines. It's one of those like at Walmart that only sells water, water bottle every time. They have a lot of water there. Okay. How about this one? So this is function. And how about this one? How about that one? Is that a function? Edward Palacios.
No.
This is not a function? And tell me why, in your opinion.
Wait, it alone?
Say it again.
It's alone or is it added
It's
to?
alone. It's a 1-point set. Is this a function or no?
No,
No? Why not?
because you can determine if where to point the whole thing.
So I'm going to show you how to analyze this. Check this out. Tell me what the domain is of this one. The domain is the set of all the x values, and we just have 2. Is that 2 repeated in the set anywhere? Do we have a repeated x value? See, we analyze the x values when we're seeing if it's a function. And if you have only 1 point, then the 2 of here cannot be repeated. Therefore, it is a function. I want you guys to get this one thing in your head. This 2 and the other 2 mean completely different things. We don't even know what the problem is. These are just representatives. This could be the button. And when you push the button, you get this candy bar. Candy number 2. You get a Reese's Fast Break. Okay, I don't know. So remember, these are not the same numbers. They are numbers. They're the same digits, but in functions, they could mean totally different things. They just represent something. You need to know the story behind the function. Okay. Now, of course, we're going to be doing mostly equations, but we do equations because there's stories behind them. Sally sold lemonade for 15 cents a cup, so you're going to get a bunch of ordered pairs. Okay. Y equals 0.15x. Well, what is y equals 0.15x? Well, it means that x is the number of cups and y is the amount spent. So these numbers aren't exactly the same. And when we're doing the functions, we only want to look at the first values, the inputs. We want to make sure each input has at most 1 output. Let's try another one. How about 1, 4, 1, 5, 2, 4, 3, 5. Is this a function? Let me call on someone. Kennedy?
No, because the x's are the same for like the 1, 4, 1, 5.
Right. So right here, you can see that the 1 maps to 2 different values. So this is not a function. And your reason, like you said, is the 1 repeats in the domain. Okay. 1 repeats. So the 1 goes to 2 different values, which cannot be done. Okay. Now let's get to functions as equations. Okay. Let me write down what I said earlier. All polynomial functions in X. I should put all polynomials are functions. So what I mean by that is, let's say you have something like this. That's going to be a function. This is called your independent variable. Because this is the number we choose on the left side. When we make a table, the X is what our input is. We decide what we want there. It's independent. We got 0, 1, 2, and 3 when we're going to graph it. This output is called my dependent variable. Dependent variable. Okay, the dependent variable is the output because it depends on X. Okay, now we have to find out if we can write it like this with just a y. Because if we can't write y equals and have a polynomial or a function of x like this, then it's not going to be a function. Let's look at 2 examples. Is x squared plus y equals 4 a function? Well, let's solve for y. I have x squared plus y equals 4. And if I subtract x squared, I have y equals negative x squared plus 4. That's one single equation in y, and that's a function. If I can solve for y and I have one equation, it's a function. Let's look at one more. And is x squared plus y squared equals 4 a function? So let's solve for y again. X squared plus y squared equals 4. I need to get the y squared alone. I get y squared equals 4 minus x squared. And in order to get rid of the little 2 up here, I've got to do the square root of both sides. But in order to do the square root of both sides, I have to do plus or minus. When you get a plus or minus here, that means there's 2 possibilities for every x. If I put x equals 0, I could get positive square root of 4 or negative square root of 4. 2 possibilities for 0 means not a function. 2 outputs. In general, if you have a y squared, you're probably not going to be a function, because you're on the plus or minus thing. Okay, so to find out if an equation's a function, you solve for y. Okay, I'm going to remove the paper. You can go back and see the video later and fill in your notes if you need to. Okay. And now we're going to talk about function notation. Okay, so you know how we do tables with x and y? Well, now I want you to imagine we're doing tables with x and f of x. This does not mean multiplication. This is called function notation. What this means is that we have a box that transforms x. You put x into it, and this function box f transforms x into an output of f of x. In the case of the Coke machine, x is the button number you push, and f is the electrical transmitter that tells you, okay, if you pushed 1, we're going to put out a Coke. F of 2, well, that's going to be a Coke. And f of 3, well, that's going to be a root beer. Let's look at a few things. If I tell you the formula for f of x is 2x plus 1, and now I want you to find f of negative 2. All you do is you find, with this input, you plug in the 2 for x, and this is your output. And we can simplify it. You get negative 4 plus 1, negative 3. Okay? This corresponds to the point negative 2, negative 3. Input, comma, output. Input, comma, output. Okay, let me give you a problem to try. If f of x is 2x squared minus 4, I want you to find f of 3. Go ahead and take a moment and do that one. Find f of 3. Type your answer into the chat box. Which letter? A, B, C, or D? Okay, that's about what I expected. A and B were the possible answers. Let's try it out. F of 3 is going to be 2 times, and notice I like to put a parentheses wherever I saw an X. Instead of X, I put parentheses. Now here you have to be careful. A lot of mistakes are made by multiplying 2 times 3 first, but we know from order of operations we have to do our exponent first. What is 3 squared? Well, that's 9. And now I can do 2 times 9 is 18. Subtract 4, and you get 14. Your answer is B. I promise that will be on a test in the future. Do you have any questions on this? Does it make sense? You know how to evaluate these. Okay. So let's see some other evaluations here. Let's do f of x equals x squared plus 2x minus 5. Okay. Let's do one more easy one. How about f of 2? Go ahead and do f of 2 and put your answer in the chat box. Put that answer in the chat box.
Can you move your paper down a little?
Yes, yes. How's that?
That's good. Thank you.
Uh-huh. Go ahead and put your answer in the chat box. Okay, people are saying 3. Okay. So it looks like I'm going to put 2 for the x there and 2 for the x there. Notice I put parentheses where I have my x's. This equals 4. This equals 4. And 4 plus 4 minus 5 is 3. Cool. Ready now? What's f of box? Hey, don't get scared. Just put it in where you saw the x's. Can I simplify this? The answer is no. That's it. Sometimes you can simplify it, sometimes you can't. Okay, let's do one more. Tell me, what is f of x plus 5? What's my input? Tell me my input.
X plus 5.
Yes, it is. So I'm going to put parentheses wherever I had an x, and I'm going to put my input there. X plus 5, quantity squared, 2 times x plus 5, minus 5. Now, you can simplify this. Go ahead and do it. You're going to have to multiply out the x plus 5 squared. You're going to have to distribute the 2 and then subtract 5. Go ahead. I'm going to give you 1 minute to do this one. Okay, compare your answer to what I put on the paper. Okay. Give me a thumbs up if you got the same answer as me. Okay. Does anyone have a question of how I got my answer? Is there a number or variable that you're wondering, where did you get that from, Mr. Gonzalez?
I had a question.
What was that,
I had
Lizzie?
a question.
I
So
can't understand, but
I said I had a question.
uh-huh.
So it's not. I'm confused. Plus 5 to the 2. The first one you did.
Okay.
Yeah.
I'll do it on the side right here. Ready? X plus 5 squared means x plus 5 times x plus 5. And we do a multiplication box here. X times x is x squared. 5 times x is 5x. X times 5 is also 5x. And 5 times 5 is 10. If I add these four things up, I get x squared. I get 10 x's because it's 5 and 5. And I get, sorry, this is 25. 5 times 5 is 25, not 10. And I get 25. So you have to multiply it out like this, using whatever method you like to use. X plus 5 squared means multiply this out. FOIL, the box, distribute, whatever you'd like to do. Does that make sense?
Yeah, I distributed the 2, so I had 2x plus 25. I did that.
Oh, so you see the 2 is for the second part right here, the
Yeah.
linear part. Okay, good.
Thank you.
Yeah. Any other questions on this one? Okay. I think I'm going to do one more thing for you guys, and we're going to go over the right way to make a table to graph something. And we kind of did it earlier on the warm-up, but I'm going to be more formal about it. Let's say graph y equals 3x plus 1 using a table. So I'm going to have, this should probably be f of x for today's examples because we're using function notation. So we're going to have our x, and over here I'm going to write f of x equals 3x plus 1. Okay? And then we're going to have an ordered pair here. So I picked like a few numbers to try out here, and I'm going to do -2, -1, 0, 1, 2. The numbers you pick for your input are arbitrary. Arbitrary. That means you can pick whatever you want, whatever you feel like. Okay? Sometimes it's better to choose certain numbers. For lines, it's all the same. So I picked numbers around the origin. So for the -2, I'm doing f of -2. And that's going to be 3 times -2 plus 1. I have to compute this, and that's going to be my y-coordinate. My x-coordinate's -2, and when I compute this, I get -6 plus 1, or -5. F of -1, 3 times -1 plus 1. That's -3 plus 1, -2. The input was -1. If I do 0, I get 3 times 0 plus 1, which is 0, comma 1. F of 1, 3 times 1 plus 1, and that gives me a 4. And 2, 3 times 2 plus 1 gives me 2, comma 7. Now, I need to plot these points on a graph and draw my line. -2, -5. That's the first point. Second point is -1, -2. Third point is 0, comma 1. Fourth point is 1, comma 4. And we've got 2, comma 7. If we did it nicely and neatly, it should be a nice straight line. And that's how you graph a line using a table. Okay.